All right, once again in lesson 4.5, we're going to be using equivalent ratios and tables. So this is on page 169 of your big book. Our essential question is, how can you use tables to solve problems involving equivalent ratios? Unlock the problem. In warm weather, the Anderson family likes to spend time on the family's boat. The boat uses 2 gallons of gas to travel 12 miles on the lake. How much gas would the boat use to travel 48 miles? So, what are we being asked to find? We're trying to find the number of gallons of gas, number of gallons the boat will use as they travel 48 miles. Okay, so we know it uses 2 gallons to travel 12. We're trying to find out how much gas it will use to travel 48 miles. Solve by finding equivalent ratios. So we're going to let this empty box represent the unknown number of gallons because we don't know it yet. It's empty. So 2 gallons will take us 12 miles. We don't know how many gallons yet. Will take us 48 miles. So we're going to make a table of equivalent ratios to figure it out. All right, so here we go. 2 to 12. So this is our times 2 column times times 3 column times 4 and so on. So this is 2 times 12, 3 times 12, and 4 times 12. I just write it like this to remind me of what I'm multiplying by. All right. So we know 2 to 12. So 2 times 2 is 4. 2 times 12 is 24. So to go 24 miles, it uses 4 gallons of gas. All right, so here we've got 6 gallons of gas. That will get us how far? 3 times 12 is 36. So 6 gallons of gas will get us 36 miles. Okay, so here we are to the number we're looking for, the 48 miles. How many gallons of gas? Well, that's 4 times 2, which is 8. So 8 gallons of gas will take us 48 miles. All right, so that means the ratio 2 to 12 and 8 to 48 are equivalent ratios. So 2 to 12 equals 8 to 48. The 8 fills in that empty box that we started with. So the boat will use 8 gallons to travel 48 miles. What if the boat uses 14 gallons of gas? How can you use equivalent ratios to find the number of miles the boat travels when it uses 14 gallons of gas? So the way we do that is we multiply both the numerator and denominator by, well, gallons. To get to 14, we started with 2. To get to 14, we multiplied 2 times 7 to get that 14, right? So if I multiply both the numerator and the denominator by 7, we will get the equivalent ratio. So 2 to 12 times 7 over 7 to get us that 14 gallons. What's 12 times 7? It's 84. So 14 over 84. So the boat can travel 84 miles on 14 gallons of gas. So as you saw in the last example, we don't have to make a table every time. Once we've figured out that we can multiply both the top and the bottom by the same number, or a form of 1, both the numerator and the denominator by the same number, we'll get an equivalent ratio every time. All right, so this time we're going to use equivalent ratios to find the unknown value. We have 3/4 equals, we don't know, over 20. Use common denominators to write equivalent ratios. So, let's see, 20 is a multiple of 4. So 20 is a common denominator between those two numbers. Multiply the numerator and denominator by what? What did I multiply here to get 20? Well, by 5. 4 times 5 equals 20. To write ratios using a common denominator. So here we have our form of 1. 5 over 5 is 1. So 4 times 5 is 20. 3 times 5 is 15, isn't it? So the denominators are now the same. All right, so the numerators are equal to each other. So the unknown value is 15 because 3 times 5 is 15. So 3/4 is equivalent to 15/20. Check your answer by making a table, so we can do that. This is our original 3 times 4, so this would be 2 times 3, 3 times 3, 4 times 3, 5 times 3. This is going to be 2 times 4, 3 times 4, 4 times 4, and 5 times 4. So 3 times 3 is 9, 3 times 4 is 12, 4 times 3 is 12, 4 times 4 is 16, 5 times 3 is 15, 5 times 4 is 20. All of these ratios in this table are equivalent, but we're checking our answer, and sure enough, 3/4 is equivalent to 15/20. We just multiplied by 5 over 5 to get our answer. All right, let's try that one more time. Okay, we've got 56 equals 8. So this time we're getting smaller, aren't we? 56 to 8. Well, what did I do to get from 56 down to 8? What did I do to 56 to reduce it to 8? I divided by 7, didn't I? All right, let's write an equivalent fraction with 8 as the numerator. Think, divide 56 by 7 to get that 8. So divide the denominator by 7 as well, because it has to be a form of 1. We have to do the same thing to the numerator as we do to the denominator. So 56 divided by 7 is 8. 42 divided by 7 is 6. So the numerators are the same. So the denominators are equal to each other. So the unknown value is, this is the unknown value right here, is 6. So 56 40-seconds is equivalent to 8/6. So we're going to check our answer by making a table. So once again, we have 2, 3, 4, 5, 6, 7. 8 times 2 is 16. 6 times 2 is 12. So here we have 24 and 18. 3 times 8 is 24. 3 times 6 is 18. 4 times 8 is 32. 4 times 6 is 24. 5 times 8 is 40. 5 times 6, whoop, got ahead of myself, is 30. 6 times 8 is 48. 6 times 6 is 36. 7 times 8 is 56. 7 times 6 is 42. Okay, so it works. You can do it either way. This obviously is much more efficient. It's much faster. Making a whole table takes a long time. But the nice thing about making a table is you realize there's many equivalent fractions between, equivalent ratios between 8/6 and 56 40-seconds. All of these are equivalent. This is just a faster way to get to the answer. Taking a look at our notes, we have find the missing value or number in the box. So here's example 1. 3/6 is equivalent to 15. We don't know. Well, how do we get from 3 to 15? Well, we multiplied by 5. So if we do the same thing to the denominator, that will give us the unknown value. 6 times 5 is 30. So the answer is the answer for the unknown value is 30. The equivalent ratio is 15/30. Here's another example. We have 18 over 42 equals 3 over, we don't know. Well, what did we do to the 18 to reduce it down to a 3? We divided by 6. So I have to divide the denominator by 6 also. And there's my equivalent ratio, the unknown value being 7. All right.